And I told you that sometimes SOHCAHTOA works and sometimes it doesn't. And the reason it doesn't always work is when you are talking about quadrantal angles. So you don't necessarily have to write this part down. I'm going to give a little explanation first, and then we're going to find these values. We know an angle in standard position starts here and ends here. Okay, so if I said you have 180 degrees, is there any way to turn that into a triangle when I'm looking at this angle? No. Same thing if I did a 90-degree angle. Well, it would end up here, but if that's my angle, I can't make that into a triangle coming from the center. So SOHCAHTOA is not always an option, which is why we use X, Y, and R. These quadrantal angles come up a lot, and we will use them so much that it's helpful if we can figure out their values. So the first one I want to talk about is 0 degrees. So 0 degrees means you don't go anywhere. So basically, you start and stop right here. Okay. We know that sine is y over r. Oh my goodness. I said y over r, but that's not what I wrote. Cosine is tangent, cotangent. I put them in a different order than I normally did. Cotangent flips. Secant would flip cosine. That's r over x. And cosecant flips sine. So r over y. So if I'm going to find these, I need values for x, y, and r. So we could take any point on the side. We did some yesterday where I gave you an equation of the terminal side, and we just had to find a point that would fall on it. So if I looked at this particular point, and we could pick anything, we know the x would be a positive and y would have to be what? If you're on this line, your y would be 0. So this is like the point, let's say 1, 0. That'd be the nicest. Okay, so then r, we know is the square root of x squared plus y squared. So we get the square root of 1, which is 1. So now I have x, y, and r. So at 0 degrees, sine y divided by r, so that would be 0 divided by 1, which is 0. Cosine is x divided by r. So my x is 1, r is 1, so 1 divided by 1 is 1. Tangent, y divided by x. So that would be 0 divided by 1, which is 0. Cotangent, x over y. What happens if you do 1 over 0? Can we divide by 0? No. So we write undefined. You're used to saying no solution, which is kind of the same thing, but in trig they usually say the word undefined when these trig functions don't work. R over x will be 1 over 1, which is 1. Cosecant, r over y, so 1 over 0 is undefined. We never saw any undefined yesterday. The only time you will in fact see zeros or undefined is on these quadrantal angles, like that. All right. So now let's talk about 90 degrees. So 90 degrees, what would be the nicest point I could pick right here? Your x would have to be, well, x would be 0 and the y would be 1. What's r going to turn out to be again? It'll still be 1, because it'll be 0 squared plus 1 squared. So r is still 1. So we do the same thing. So y divided by r. 1 divided by 1 is 1. X divided by r. So 0 divided by 1 is 0. Tangent, y divided by x. So 1 divided by 0, can we do that? No, so that's undefined. Cotangent, x divided by y, so 0 divided by 1 is 0. Secant, r divided by x, so 1 over 0 is undefined. Cosecant, r divided by y, so 1 over 1 is 1. All right. So far, so good? Let's figure out 180. What point would I have to use for 180? My x would be -1 and y is 0. When you find r, if you do -1 squared, r is still 1. When we're picking these nice points, it's turning out that r is 1 every time. Okay, so sine y divided by r. So 0 divided by 1 is 0. Cosine x divided by r, so -1 divided by 1. Tangent y divided by x, so 0 divided by -1. Cotangent x divided by y, so -1 divided by 0. Secant r divided by x, so 1 divided by -1. And cosecant r divided by y. Mm. 270. So 270 is down here. What point would we use for that?
0 and -1.
And again, what would r turn out to be?
1.
1. So sine y divided by r, -1 divided by 1, is -1. Cosine x divided by r, so 0 divided by 1 is 0. Tangent y divided by x, so -1 divided by 0, undefined. Okay. Cotangent x divided by y, so 0 divided by -1 is 0. Secant r divided by x, undefined. And cosecant r divided by y is -1. What are the only answers I'm getting here?
1, 0, undefined, or -1.
Yep. 1, -1, 0, and undefined. Those are the only possible answers on these quadrantial angles. All right, last one, 360. Where is 360 at?
It's the same as 0.
It's the same as 0, isn't it? It's coterminal with 0, so it's the same values I had in my first row. So 0, 1, 0, are we going to use this? These values are going to come up a lot. It's not that I expect you to go home and study this table and memorize it. Okay, that's not what I'm asking. What I expect is that you could figure out these values and use them in a problem. What I usually do if I need to figure them out, I suggest just drawing the picture and say, okay, in this picture, I know this was the point 1, 0, 0, 1, negative 1, 0, 0, negative 1. And what's R always? 1. And trying to use that to help figure them out. So there is a section on the homework tonight that's just going to say like sine of 270 degrees. I know, I just gave you a table with all of them. So I know you can do that section in about 2 minutes just by copying them off the table, but that's not really the purpose. I want you to think about drawing this picture if you need to, draw it on your paper, and try to figure them out. Okay, and then use the table we filled out in class to double check yourself. But that section is to give you practice coming up with these values when we need them. Any questions there? So let's do a couple examples. Let's say, if I asked you to find, how about the cosecant of negative 810 degrees. What would I need to do with this? Right, we need that coterminal. We want something between 0 and 360. So if I take negative 810 plus 360, okay, it's still negative, so I have to add 360 again. Still negative, add 360 again. Alright, so then what I want you to do, what is the definition of cosecant in terms of x, y, and r?
R over Y.
So think about it, 270. 0, 90, 180, 270. At that point, my x is 0, my y is negative 1. So, r in this picture is always 1. The y at this point is, and we get negative 1 for our answer. Okay, double check your table. When we did cosecant of 270 degrees, did we have negative 1 in there?
Yes.
Yes. So use your table, check yourself, but figure them out without just jumping to that answer. Is that one okay? What if I gave you, let's do, first thing I want to talk about is when you have exponents. The notation, when we have things squared, they always put the square on the trig function itself, but what this means is find the secant of 180 and then square your answer. Minus 3 times whatever the sine of 360 is, and then square that answer. Plus the cosine of 180. So we need to figure out these values. So think about that little picture. So this is the point 1, 0, 0, 1, 1, 0, and 0, negative 1. And R is always 1. What is the definition of secant?
R over X.
It's the reciprocal of cosine. Cosine is X over R, so this is R over X. So at 180, so 180 puts me here. My R is 1 divided by negative 1, negative 1. 3 times the sine of 360. Where is 360? All the way around, we're back to 0. Okay, sine is y over r. So at that point, my y is 0, r is 1, so 0 divided by 1 is 0. Cosine of 180. What's the definition of cosine? So at 180, x is negative 1, r is 1, so negative 1 divided by 1 is negative 1. We work this out, negative 1 squared is 1, 3 times 0 minus 1, so we get 0 for the overall answer here. Is that okay with everyone? So I know these problems will go a lot faster if you just copy the values off your table. I am going to give you plenty of class time because I don't want you to do that. I want you to think through them and practice figuring them out. So I am giving you time to do that so that you don't feel like you need to rush and just copy the values from your table to get your homework done. So you have the homework from yesterday, and if you still have some left, then finish that, and then we're going to add to it I'm going to do 56 through 76 even and 80 through 86 even. And the deal is, if I'm giving you this class time, you're thinking through them, not just copying the answers over.